Okay, so welcome to day 2 of Java. Today we're going to teach you a bit more about some of the things you can do with Java, namely all sorts of operations you can perform on variables. Arithmetic operations, Boolean operations, string operations, and more. So, let's get started. First, we want to start with a bit of homework review. Here's a little quiz to test your knowledge of what we learned last week. So how would we store the following data in Java? 3.0, 3.7, 3, the letter A, or the sentence, my name is Bob. Once you have all the answers, just write them down or type them somewhere and call us over and we'll check if they're correct. And in like 2 minutes, we'll review it. Okay, great. Looks like all of you got it. So now, also, what was the purpose of changing print line to print? What did that do to the program? It put everything on one line, right? And yeah, any other lingering questions about the homework? Cool. Okay, we'll move on then. So, also, what data type does each one of these lines get from the user? Okay, good job, guys. You got all of them correct. So, now let's move on to operations. That's the main focus of this chapter. How you can operate with variables. In the lemonade stand, operations were critical to making a program that was actually useful. We had to work with variables and manipulate them using operations. So Java provides an easy to use set of operations for integers, decimal numbers, strings, and booleans. And you can use them on numbers or you can use them on variables. And this gives you the power to change how your code works based on what variables are declared to. So this is a pretty basic summary of arithmetic operations. All the basic operations you expect to be there are there. Addition, subtraction, multiplication, division. Then we have one more esoteric operation, the remainder, which is basically it takes the remainder that you'd get after division. So what's the remainder you'd get when you divide 7 by 4? 3, right? So that's what the remainder operation does. We should probably in a bit we'll show you examples of how exactly these work. But what would the remainder be when 22 is divided by 7? 1, right? So what is 22 remainder 7? 22% 7? It's 1. What about 5% 3? It would be 2. Yeah. So that is the essence of the remainder operator. And it can be pretty useful for checking whether numbers are even or odd. We'll get to that later though. So now we're going to do some examples with operators. Let's open up a new file and call it, we'll call it operators.java. Keep it simple. Call it operators and check the main method. Make sure to put it inside Java Workshop. Okay, so let's first try some simple examples. Let's declare an integer a and set it to 5, and an integer b and set it to 16. So we can, for example, print out the value of b minus a. And yeah, it works just like you'd expect. You'd get the value 11. Okay, let's say we do b times a. It should work just like you'd expect. You'd get the value 80. There's nothing funky about this. Now, what do you think would happen when you do b divided by a? The slash sign. What's 16 over 5? When you divide 16 by 5, what would you get? 3.2. Yeah, but the problem is when you divide two integers, the result has to be an integer. And what type is 3.2? It's a double, right? So that would that would kind of go against this idea that when you divide two integers, you get another integer. So the fact is, when you divide two integers, when you divide 16 by 5, instead of getting 3.2, it rounds down to 3. And it always rounds down no matter what. Even if it was like 19 over 2, you get 3.8. It still rounds down. So, let's try it. When you print out b over a, you get 3. Even if you change b to, for example, 19, you still get 3. So, we've seen that division in Java behaves a bit funkily. Is there anything else? Well, when you use doubles, for example, if you made a double, then division would work normally because you're telling the program that, okay, these are decimals. You don't want to treat them like decimals. And yeah, you can work with doubles and other data types, and they'll be better for if you want to divide things and you want to get the exact result. Yeah. And you can definitely multiply doubles with integers, it'll just round up to a double. But one more thing, when you have doubles, sometimes you can lose precision. Like, let's see this. So let's make this a double, and now see, we multiplied two things that were fairly straightforward, and oh yeah, this is division, but yeah, we multiplied two things that were fairly straightforward, but the result we got as a double isn't exact because the way Java represents doubles inside memory is gonna have, it represents them as ones and zeros, so it's gonna have a bit of error, and instead of saying 0.7, it'll say 0.6999. So when you want to be precise, you can't necessarily use doubles because there'll always be a bit of error with the precision. Okay, so those are the main quirks of arithmetic operations. Other than that, they work pretty much as you'd expect. Okay, and we already worked with lemonade stand. Yeah, they work pretty much as you'd expect, so we're not going to do another example with these. Okay, and another kind of side note is that you can actually add strings as well. Let's do some other things. So we can create one string s equals, like, say, I don't know, yeah, let's just call it string. And then we can create another string h equals concatenation, which is a complicated word for adding. And then we can pretty much, we can try printing out the sum of s and h. So yeah, let's print this out and see what it gives us. It prints out the combination of string and concatenation. String concatenation. You could, instead of printing this, you could assign this to another variable. But yeah, the idea is basically the same. When you add two strings together, then you kind of smush them together. You put one after the other. And even if one of these things is a integer instead of a string, then they still combine, right? It's like it adds the integer to the edge of the string. So, or it'll add this double value to the end of the string. So, the addition operator is smart like that. So it can add two integers, or you can add two strings, or you can add an integer and a string. So Java makes your life easier in some ways. Okay. So that's pretty much all there is to it. The last thing we want to go over is the operations you can do with booleans. So these operations that we have in this table over here, we don't expect you to memorize them, but you'll probably get to know them through a lot of practice. These operations all return booleans, and some of them also operate on booleans. So the first operation here is equals. It returns true if something is equal to something, and it returns false if that thing is not equal to the other thing. So, for example, 2 is equal to 2 would return true, because it is true that 2 is equal to 2. And yeah, on a similar note, the not equal sign says that it returns true if two things are not equal. So, 2 not equal to 2 returns true because 2 is not equal to 2. It is true that 2 is not equal to 2. You can sort of think about it in that way, although it might be a bit complicated at first. The greater and greater than or equal to sign tell you they return true if 89 is greater than 60 in this case, and it returns false if you had like 49, because 49 is not greater than or equal to 60. And the less than or equal signs work in a similar way. So yeah, 49 is less than or equal to 60, so the value here is true. Okay, so you can definitely test that out, and I think we probably should. So yeah, let's make some values. So let's say Boolean result equals, it's true whether A is equal to B. Those two doubles are equal to each other. And now let's print out whether it's true. So what would you guys predict? It seems that A isn't equal to B, so the result should be true. No, sorry, the result should be false. And indeed, it is false. If you make A equal to B, like if you set B equal to A, then yeah, suddenly the result is true. So it checks for whether they're equal. Then let's see whether A is greater than or equal to B. This A is a lot bigger than B, obviously, so this does return true. And then is A less than or equal to B? No, it's not, so this just is false. So yeah, this is kind of a straightforward way to see how these equality operators work. So yeah, I'll give you guys a bit of a moment to catch up and type these if you haven't already. Okay, so we're all good now, I think. Let's move on to the last topic we're going to touch on, which is about and or conditionals. These are actually, they operate on Boolean values, and they return Boolean values too. So we'll see how they work with this analogy of a lamp. So we can have a Boolean value. We have a lamp, and the lamp only works if it's plugged in and if it's turned on. So we can represent a lamp. It only works if it's plugged in or turned on. So let's say Boolean is plugged in. And we'll say initially it's not plugged in. And then Boolean is turned on. We'll say it is initially turned on. Okay. And then Boolean lamp works. So yeah, we'll say the lamp is turned on initially, but that still shouldn't matter, right? Because the lamp isn't even plugged in. How can it work? So how can you represent these? Like, you want lamp works to be true. You want the lamp to work only if both of these are true. In Java, there's actually a command for that using the two double and signs. So you can say is plugged in. If the lamp is plugged in and it is turned on, then it works. And now we can print out whether the lamp works. Okay, so it says false. The lamp doesn't work because it's not even plugged in. And if you try different values for these, you'll see it only works if both of those values are true. Great. Okay. And another similar operator is the OR. So if you made this OR, then it suggests that the lamp can work if either it's plugged in or if it's turned on. Like it has two different power sources, like a battery and a plug. But it'll work if either of them are in. So yeah, that would be interesting. Actually, I challenge you guys to come up with a nice metaphor that kind of matches the lamp one for OR. And the OR symbol is, it looks like this. It's shift backslash. Okay, great. Heard some really great ideas from you guys. Now I think we're pretty much done with all our exploring with operators. If you have any questions on how they work, then feel free to ask. We can pause for a couple moments to give you guys time to write this all down. Okay, good. So now let's move on to the final project for today. We've already gone over most of the input stuff last week, so yeah. One last thing. Actually, yeah, one last little thing. Actually, I think we can create a new program for this. So let's say create a new class and let's call it essay.java. We're going to write an essay together. Has a lot to do with manipulating strings in general. Okay, so hopefully we're all on the same page. So let's write a simple essay. This is my essay. I would make it longer, but I'm typing it in clips instead of on Microsoft Word. Okay, so that is, let's say that's the raw material for your essay, something like this. I hope I get an A. Let's say that's the raw material for your essay. So, would you get an A for this essay? Even ignoring the content? No, your lit teacher would roll in their grade because you have to have proper formatting for an essay. Like, instead of having it all on one line, it should look like a paragraph. So, let's try to insert some new lines. How do you do that? When you press enter, you immediately get tons of errors. Actually, no you don't, because Eclipse helps you. But even if you press enter inside it, then it doesn't add new spaces. So actually in Java there's a very special character that signals starting a new line. And you have to say \n. And if you sprinkle in a couple of \n's, then you can actually turn it into a paragraph. So now it looks like it's formatted like a paragraph. But also, didn't your lit teacher say that you have to indent the starting of every line? There isn't an obvious way to do that in Java other than like adding 4 spaces yourself. But there's actually another special character. Just like \n creates a new line, \t creates a tab indent. So now let's try it, and it gets indented enough. So that's great, right? And one last thing I want to show you. Let's say you want to add a quotation into your essay. So, any ideas for a good quotation?
Use the Force, Luke.
Okay. Who said that?
Master Yoda.
Okay, so Yoda once said, use the Force, Luke. Okay, but the compiler completely bugs out on us. Why? Because it seems to think that these parentheses are ending the quotation. It doesn't realize that this is actually a quotation inside a string. So the way we get rid of that is by putting a backslash behind it. And then that tells the compiler that this is just supposed to be a regular printed quotation, not a quotation that ends the string. And we have to do the same for the other one. Now we actually get a quotation printed out. And good, we're almost done. We actually might not even get any points off for formatting for this essay. So those are the basic things you can do with string formatting and special characters. And that should make your work with strings a bit easier. And yeah, another trick, you can often add variables in. Let's say you have int a equals 5. You can often include variables by adding them to the end of the string. So you don't need to print things twice. You can make a combined string that includes your variables as well. And see, now your essay ends with the 5. Hopefully that's your score. Okay, so yeah, that's pretty much all we're going to cover in this class. And the rest of our time is going to be spent on introducing you guys to a mini project, which we call report card. And the idea is you want to have the user input 3 test scores using the scanner stuff we learned about before, and then store the values inside certain variables. Then after that, we want you to calculate the average inside your program, and then we want you to output a formatted report card kind of thing. So using all the special characters like tabs and newlines that you learned about, print out test number 1, their score, and whether they passed. And then test number 2, their score and whether they passed. So on. And then the overall average and whether they totally passed. Okay? And then, yeah, if they passed, it's if their test score was above 60. And, yeah, so you should print this all out in a good format. And then it should really require some of the operations we've been using, or almost all of them. We'll get you started, but we want you guys to actually try this on your own. So remember to, you can look up input-output as a good guide to get started. And then remember to divide the program into 3 stages. So you want to read in the input, and then you want to calculate the values, then you want to print everything out. Okay, looks like most of you are done. So if you're not done, I want you guys to finish this at home. And we'll also assign some other homework. We want you to go to versal.com and work on chapters 4 and 5. So do all the quizzes there, and ideally do some of the exercises. Yeah, ideally do some of the interesting exercises, some or most of them, as much as you have time for, of course. And definitely, you should finish off this report card project if you haven't already. Okay, thank you. Thank you for coming today. Hope you enjoyed it.